Right, today we move to hypothesis test for Poisson distributions. Okay, the procedure for carrying out the hypothesis test for the mean lambda of Poisson distribution is similar to the binomial proportion. Similar to the binomial distributions. The null hypothesis, when we want to set, normally for Poisson, we will set the only parameter for Poisson is lambda. So this is for the benchmark that we given in the question, right? So this one always the values that you need to compare. Okay, so normally we set this one as a benchmark. Okay, right, then the hypothesis, the alternative is similar to what you're going to test. So you have, as you know, you have three types: larger, smaller, and equal or not equal. Okay, so you also have three types, right? So for the first one, you have upper tails. Second, you have upper tail. Second, you have lower tail. And for the third one, you have two tails. So this is important for you to determine the how many percentage that distribute to the different tails, right? So for the question that normally the standard question will have a 5% of significant level, but the significant level can be in any values, depends on the question. And we repeat again, in order to test the upper tails, normally the question will have increase, okay, improve, and something that you are increasing, okay. And if you want to test the lower tails, you have something that mention about decrease, reduce, or sometimes for the radiative question will have a decay or some things, right? And for the two tails, okay, the question will say any changes or not, any changing or not, is the same, any difference or not. So in that one is two tails. If two tails, you need to distribute the percentage of a significant level to evenly to upper and lower tails, right, in order to compare the question, right? So for this Poisson, the full procedure is similar to last week binomial distributions. Okay, I have uploaded a document for specifically for today, question 1 to 4 for Poisson distribution, and a little bit about the type 1 and type 2 error. So now we will proceed to the question 1. Okay, question 1. Question 1, the number of misprints on the advertisement page of the Daily Informer has a Poisson distribution with a mean 6.4 misprints per page. When a new time setter is employed, 3 misprints are found on a randomly selected advertisement page. The new typesetters claims that the mean number of misprints has decreased. The test this claim at the 5% of significant level. Okay, so question already mentioned Poisson, so definitely it's Poisson already lah, no need to guess. Okay, so you can set your, because when you want to run the test, you may set your parameter first. Okay, so 6.4 is the benchmark that you need to compare, and the hypothesis lambda equal to 6.5. And the alternative hypothesis H1, the question asks you to test is it has decreased or not. So decrease means smaller. Right. So this is your these are your hypothesis, H naught, H1. So after you have these two, you may proceed to run the test. Okay, and look at the values that you found from the survey. You found that when a new time setter is employed, 3 misprints are found randomly. Okay, so your test value is 3. So now you can run the test, and please remember that for this discrete test, you have to find the probability at the end point, from the end point. So for this question, what you need to find is P, because you want to test the smaller, okay, smaller, so mean X smaller equal to 3. You have to include the test value, so smaller equal to 3. So you need to find the probability for this this area. So now we proceed to find the probability for this area. So when we find Px smaller equal to 3, so for Poisson, you can put this, the e, the exponential at outside. 6.5, 6.222 factorial, and last one plus 6.3 power of 3 factorial. Okay, so if you cannot remember the formula, don't forget, open the formula booklet, have a look, all the things is inside. So once you have this is equal to, you can calculate, and this is equal to 0.1118. You may have other things at the behind. So once you have this, you need to compare to 5% of significant level. So 5% of significant level means 0.05. So this value is larger than 0.05. So mean, if it larger means means 3 is not in the critical region, right? Not in the critical region. So if not in the critical region, mean reject H1 in favor of H0, right? Because not in the critical region. So once you have this, and don't forget, this is a general statement, right? For you to clarify the situation. So once you clarify the situation, you may proceed to do the final statement. The final statement is, so you can say at 5% of a significant level, the claims that the mean number of misprints has decreased is not supported. Okay, so you can say the claims that the mean number of decrease of misprints is not supported. So you can have your own sentence, but must according to the story that mentioned above. Right, so now we proceed to second question. For second question, Z is the manager of a local football team. During last season, the number of goals per match scored by the team follow a Poisson distribution with a mean 1.4. Prior to the start of the new season, the team took part in the intensive coaching sessions. Jack decided to use the result of the first 2 matches of the new season to test whether the team now score more goals than before on average. In the first 2 matches, the new season, the total number of goals scored by the team was 6. Okay, first part, carry out the test at a 7.5 significant level. query is stating your hypothesis and your conclusion. Okay, part 2, state which a reason whether the conclusion will be the same at 5% significant level. So for part 1, this question, be careful a bit because the question say at last season, right? So the mean with the Poisson distribution, the mean is 1.4 one season. So now you need to test two methods. So what happened? So you need to, based on because the Poisson question always have this interval, they want to test you the interval issue. So normally when you read the question, must read properly. So when you want to start the hypothesis, sorry, not hypothesis first, you may start your parameter first. So now you consider two methods. So your lambda will become 2.8. Be careful a bit. 1 is 1.4, so 2 is 2.8. Okay, so now you can set your hypothesis. Lambda is equal to 2.8 and H1 lambda is, you want to test whether the team now has more goals, so larger, more, okay, so larger than 2.8. So once you have these two, now you can start your test. The test value is, because you score 6, so and you want to test the larger side, so you should find px larger or equal to 6. And remember that Poisson you don't have endpoint, so you should use 1 minus p x smaller equal to 5. Yeah, and so this is equal to 1 minus e negative 2.8, 1 plus 2.8 plus 2.8, 2 factorial 2, and plus until 2.8 power of 5 over 5 factorial. Okay, all this you need to carry, carry written. You cannot skip. Right. So the behind part, this one, the thing that in the bracket, you may use this calculate one time in your calculator and direct multiply the e negative 2.8. Right. So once you simplify, you may get this equal to 1 minus 0.9348. Okay. So this is better you put after you simplify, and you should get 0.06511. 0.6511. So now you need to compare to the 7.5%. So this is larger or smaller than 7.5%. So this is smaller than 7.5%. Right. So this one you should convert to 0.075. Okay, smaller than 0.075. So if smaller means this is in the critical region, right? If in the critical region means reject H naught in favor of H1, right? So once you have this, you can say that the claim that the team, you can say at 7.5% significant level, the claims that the team now score more goals than before on average is supported. Okay, so you can say at a 7.5 significant level, the claims that the team now score more goals than before on average is supported, right? So this is the statement for part 1. For part 2, state with a reason whether the conclusion would be the same at 5% significant level. Okay, so now they want to ask you if the significant level change. So what happened? So if significant level, just now what we get is px larger equal to 6. is equal to 0.06511. So this, if you compare to 5% significant level, so this one will be larger than 0.05. This one larger than 0.05. So if larger than 0.05 means it's not in the critical region anymore. So you can say that at 5% significant level, the claims that the mean number of goals per match has increased is not supported at 5% significant level. You can say that. Okay, so for part 2 is not supported, right? Okay, so if you have any problem, you can text me. If not, then we will proceed to third question. Okay, so the previous two questions is about the Poisson distributions. So now we move to the type 1 and type 2 errors. Okay, so any problem? If not, then we proceed to type 1, type 2 error. If any problem for this, you just text me or you just message me. Okay. So for type 1, type 2 error, type 1, type 2 error is similar to the z-test. So if this is similar to z-test, means the probability of type 1 error is equal to the probability of u. So remember, reject, the key one is reject hash not, right? So, and the probability of type 2 error will be the probability of u accept hash not. Okay, so this is the type 1 and type 2 error. Okay, the general one. So the question may change a bit lah. So this will be same to the z-test. So now we proceed to question 3. See what the question mentioned about that. For question 3, a manufacturer claims that 20% of the sugar-coated chocolate beans are red. George suspects that the percentage is actually less than 20%. And he takes a random sample of 15 chocolate beans and perform a hypothesis test with a node hypothesis p equal to 0.2 against the alternative hypothesis p smaller than 0.2. He decides to reject the node hypothesis in favor of the alternative hypothesis if there are 0 or 1 red beans in the sample. Part 1, in reference to the situation, explain what is the mean by type 1 error. And part 2, find the probability that type 1 error in the George test. Okay, in order to do this, before you start, you may start to set the parameter first lah. Okay. This is a parameter. So, part 1. The probability, what the mean for type 1 error? Type 1 error means happen when you reject hash not, right? So when you will reject hash not. So you can put a statement according to the context. So you may say that George make a type 1 error if he concluded that the percentage of red bean is less than 20%, when in fact it is 20%. Okay, I'll repeat again. Judge will make a type 1 error if he concluded that the percentage of the red bean is less than 20%, but in fact it is 20%. Okay, so conclude it is less than 20%, but actually is 20%, just like that. Okay, so this is part 1. So for part 2, find the probability of type 1 error. Okay, so the probability of type 1 error means is equal to the probability of you reject H naught, right? Okay, so when you reject H naught, okay, read the question. When you reject H naught, P will be smaller or equal to 1. Right, so when you reject H naught, Px is smaller or equal to 1. So you need to find the probability of Px smaller or equal to 1. So it's equal to Px equal to 0 plus Px equal to 1. So you need to plus these two. So based on this will be C0, 0.20, 0.18, 15 plus 15C1, 0.21, 0.18, 14. So you can calculate this value. So by calculate this value, you should get the probability of type 1 error is equal to 0.1671. Right, so you may simplify to 3 significant level, so mean is equal to 0.167 for part 2. Right, so this is for question 3. For question 4, a single random observation is taken from a Poisson distribution with mean lambda and used to test at 5% significant level. The not hypothesis lambda is equal to 8 against alternative hypothesis lambda smaller than 8. Find the critical region and hence find the probability of making type 1 error. Okay. So part 1, find the critical region. So you already have the hypothesis, so before you start to calculate, we should set the parameter. Okay, and H naught lambda equal to 8, H1 lambda smaller than 8, as mentioned in the question. So if you want to find the critical region, you should find the total probability region by smaller than 0.05. So for this kind of question, you have no choice, you have to trial and error. So let's see, normally it's not at the first one, the last one. So we are not consider x equals 0. So normally we take 1 or 2 or 3 first and see what happen. So I take 3 first. So I see Px smaller equal to 3. So see what happen. So e negative 8, 1 plus 8, 2 factorial plus 8 power 3 factorial. Okay, so by calculating this, simplify this, you may get 0.04238. Okay, so this is still smaller than 0.05. So mean this is still in the critical region. Okay, so we need to determine the last value that's still in the critical region. So now we proceed to the next one. Now we try Px smaller than or equal to 4. And just now we just use the 0.04238 plus Px equal to 4. Okay, so you should get 0.0996. So this value is larger than 0.05. Okay, 0.05. So means this is out from the critical region already. So means 4 is not longer in the critical region anymore. So your critical region based on the value calculation is x smaller equal to 3. Your critical region x smaller or equal to 3. Okay. So first part. So now you need to find the probability of making type 1 error. So type 1 error means the probability of type 1 error mean the probability of you reject hash node. So when you will reject hash node? So you reject hash node when you p x smaller or equal to 3. Okay. So what is the probability that x smaller equal to 3? The probability is you get already calculated from top is equal to 0.0424. So this is the probability of type 1 error for this question. Okay, so this is for question 4. Right, I have posted an assignment on. The assignment is attached together with this question, so as at the below, so you may try it and post on the group, post on the link. So tomorrow will be the last lesson for the step 2. Once we're done, we will use some time to clear mechanics. Okay, so prepare for it. I think once we start the school, we may start the assessment 2 and 3 maybe together. So 2 and 3 will be cover paper mechanics 1 and step 2 together. So prepare for it. I think we still have few chapters for mechanics, but don't worry, I think before we start school, maybe in 2 to 3 weeks, okay, we will clear, maybe in 2 weeks we will clear mechanics also. Once we're done, depends on you, see we all want to start the new lesson or not. If not, then we just do some revision for this semester. Okay, thank you.